So what we have done, just to recap the previous chapter, that is chapter 0 actually, which we did on the numbering system. So I believe we have already done a proper recap on the numbering system. We saw the base numbers, we saw how to perform the conversions, and we saw how hexadecimal octal is a has a natural correspondent and also acts as a compact representation. And we also saw that most of the time we will need to convert from binary to decimal and vice versa. And then we saw in the exercise when we want to convert the decimal value into 2's complement numbers. So we need to perform that conversion. So we did binary addition, and then we went to 2's complement. We saw negation, we saw the addition and subtraction, we saw the subject matter of overflow, and also the last but not least, we saw the binary coded decimal. So with that we have concluded. Yes?
Sir, can you speak louder? It's night. I cannot hear you.
Nighttime can't hear you. Okay. Thanks for the feedback. Can you hear me now? I think because it's sitting under the AC. Never mind. Can you? So it's good. Please give feedback like that, and I'll try to speak louder. Okay, the next thing I need to get is a portable PA. Not personal assistant. Big announcer. So, with that we have concluded chapter 1. Numbering system. So any questions on the numbering system? Especially I have taught you the shortcut on how to actually convert into positive values and also the negative representation, right? And we did the tutorial questions already. So what we are supposed to do in the tutorial we have already done. Actually the tutorial that we did in class was the last week's tutorial. We missed last week's tutorial, right? Nevertheless, we have already done the tutorials for chapter for the numbering system. So, and I gave some exercises for you to do, right? The remaining numbers. Did you all try? Please try again. I'm going to constantly remind you that this subject, if you don't solve your doubt every week, then you're going to have trouble. And don't come at the end of the semester telling that, sir, I got bad grades and can you please help remark. This recently I did a lot of remarking, and this is a waste of money actually. From other lecturers, when they did remarking, you're not getting much information, so don't feel sorry later, but then work now. So enough of motivation talk. We're going to enter now into chapter 1, which is actually introduction to PIC 18. Remember, PIC 18 is actually the microprocessors or microcontroller that we will be learning throughout this whole semester. And the manufacturer is Microchip. So the course outcomes for this first chapter is able to perform arithmetic and logic operation with number systems, which we have done earlier, and codes used in microprocessor. And you also will start using some programming language to achieve or to perform those arithmetic and logic operations. And the second one is you should be able to describe the hardware organization of a microprocessor based system, architecture of PIC 18, its register model, addressing modes, memory model, and its technology. Now all these things will be tested in your test 1. So if you want to know what's the feel like, what are the questions you're going to ask, a certain question is very popular and you can't run away much from asking a question. So throughout the years, we have already asked the question in different way. So if you see all the test 1, pass the test 1, you should know how's the format or what is the thing that, what are the things that is you'll be tested on, which is basically on this course outcomes. Is it okay? So now we're going to start off first with what is a computer. Now basically when you take a computer is actually divided into 2. So we have the software and also we have the hardware. Now what we're going to do now is we'll leave the software portion for now. We'll focus on the hardware portion. Is it okay? Are you all following? So when you take the hardware portion, this is actually the computer hardware organization. Now basically any computer hardware organization that you take, it consists of these modules. The first one is the processor, second one is memory, and also the input-output units. These 3 components will make up to a computer hardware organization. So this is the breakdown of the hardware organization. As you can see, here is the processor, this is the memory, this is the output unit, and this is the input units. Basically, these output and input units can be categorized as input-output units. So that's why I just say we have 3 modules. So what are those modules and what are the functions of those modules? So we see the first one, which is actually the CPU, Central Processing Unit or processor. So what does it do? It is actually responsible for performing all the computational operations, coordination of the usage of the resources of a computer. So the first one, I think you know, that the CPU performs arithmetic and logic unit. So this whole thing is known as the processor. And inside processor, there are actually, it's broke down into control unit, arithmetic, logic unit, and registers. We shall see that later. So for now, we are focusing on processor, memory, output, and input. So what does the processor do? It performs this arithmetic logic unit. And also, what's the second one? It also coordinates the usage of resources of a computer. So what does it mean that you have the memory, you have the input and output. All these resources to read the data from the memory or to write the data into the memory and to take the data to perform some computation, and also if you want to display it out or you want to take an input, all those are actually controlled by the CPU. So that's why it is actually telling coordination of the usage of resources of a computer. Is it clear? This is a simple layman's term. Anyway, this one they won't ask you. It's for you to understand. The second one, you have the memory. Now, if you see, this memory is actually further broken down into two memory. The first memory is program memory. The second one is data memory. Now, from the name itself, you can make it up what's the function of the memory. So, the first one you have program memory. So, what do you do with program memory? It's a memory used to store the program. Programming is something like akin to your operating system. Are you following? Is it difficult to understand? And then you have data memory. Now what do you do in data memory? You store data. So we have two types of memory. Now for example, in your computers, you have hard disk, right? Now in a certain protected partition of your hard disk, you have your operating system installed. Now if you open your Windows Explorer, you can see it's always a C drive, and you can see the operating system there. Now assuming that you are working on a Microsoft Word application, now when you're actually writing the Microsoft Word before saving, temporarily all whatever that you have typed is actually stored, right? But you have not saved in your hard disk yet. Where is it stored? RAM. Yes, it is stored in your RAM memory. It's a temporary storage where you store your data. So something similar to that, in the program memory is where you store the programs. Now for this subject, you will be typing the program codes. So the program memory is dedicated for you to store the program, whereas the data memory has the data. So if you want to perform any addition, subtraction, or whatever operation that you want to do, any data, they must be stored in data memory. Is it clear? Are you following? Program stored in program memory, data stored in data memory. Now don't worry about how are we going to do that. How is it? That one will come later. For now, just understand the concept that program is stored in program, data is stored in data memory. As simple as that. Is it okay? And then you have the output units. It's quite simple. To present the output result, for example, the LED screens, printers, or whatnot that you have, those are actually output devices. So in your computer or laptop itself, for example, the VGA port, is it an input or output? You know what's VGA port, right? Do you know what's a VGA port? Yes or no? VGA port is the port to generate the visual graphic from the laptop or monitor, laptop or your desktop. So that means that port is actually an output. So at the same time, you also have input units. Can you identify any input units on your computer? The keyboard is one input unit because it provides input. The mouse, and you have so many other input devices that you can actually use, scanner, whatever. So do you understand? If when you take a computer hardware, the computer hardware have 4 segments or 4 modules. The first one is, you all can talk now. It's better if you talk in class. It actually helps the learning process. That's why I ask question for you to answer. And if you realize that if you participate in the class discussion on the floor of the class, you will realize that you learn something. So what are the 4 modules of computer architecture? The first one is CPU, the second is memory. The memory is broken down into 2. What are those? Program memory and data memory. And then you have the output unit and also you have the input unit. Is it clear? This is very, very easy. Can you move on to the next one? So before that, I just would like to tell the output unit and the input units we will cover in chapter 7. Is it okay? We're going to see that in chapter 7. Now we're going to progress to see what is in detail about the CPU and we're going to see on the memory. So these 2 modules of the computer architecture we'll see chapter 7. So moving on, now we have 4 modules, right? CPU, memory, output and input. Output, input, okay, we close chapter now. We're going to see by in chapter 7. So remaining 2, CPU and also memory. So now we focus on the first one, which is CPU. So when we take CPU, CPU has 3 components. Now if you remember the control unit, arithmetic and also the registers. So these are the 3 registers, ALU and also control unit. Now what is registers? Now register is actually a storage location inside CPU. I'll read this one first, explain, then I'll explain in detail. It's a storage location inside CPU. It is used to hold data or memory addresses during the execution of instruction. It is very close to CPU, which means it provides fast access to operands for program execution. I know you're not familiar with these terms yet. You'll get to know soon. So despite this, some of the technical words, this register is actually inside CPU. So what does this register do? It can actually hold data or hold memory addresses. Now just to give you a very simple example, have you heard about cache memory? Do you know what's the cache memory? Cache memory is something like this register. You also have the, not the cache counter, cache memory, C-A-C-H-E, cache memory, not cache, it's cache memory. Okay? A very good example is your internet browser. I'm sure all of you have used internet browser. Now what does your internet browser does is, your internet browser also has its own cache memory. So what does it do? It actually stores the most frequently visited websites. So when you actually type Facebook, then you click enter, you will notice that the page loads very fast. The reason is, all the web page graphics and certain important things are actually stored in the cache memory. So when you click load, it will actually, it doesn't have to go to the server. Now I'm going to data company. Never mind. It doesn't need to go to the server to retrieve all the information. Some of the basic thing is already stored in the local browser itself. That's why sometimes if you go and see inside your browser files, there are a lot of images and things like that, right? Sometimes some of the files. So those are actually some of the components of the element. So when you type, when you click enter, the page loads very fast. Now if you don't believe me, you go clear all your cache memory. If you go to setting, you have to clear the setting. Don't make something. You clear the cache and everything, the cache memory. Then you try to load back the web page and see. So in internet doesn't make any difference. Oops, it's recording right. So anytime you clear the cache memory or don't clear the cache memory, same speed. But then really, if you try to clear the cache memory, you try to load back the page, it will take slightly longer compared to the earlier one. So do you understand the principle of the cache memory? Similarly, in your computer, you also have the cache memory. Now in PIC, we call it as register. Sorry, the first time I'm using this, so I'm getting used to it. We get this register. This is actually gifted by students on my birthday. So that's very sweet of them. Last person I got. So learning how to use it. So, do you understand this register? So this registers allows fast access to the memory, or if you are using certain data quite frequently, instead of loading it here, you can keep the data here. Because arithmetic logic unit is just the neighbor for this register. So that means if you store certain data here, if you want to access the data, you have to go to the memory and cache the data and come back, and then only you can perform the computation right. So if you notice that certain data you can actually store it here. So you don't have to go all the way here to retrieve your data. You just take it from here. So what it makes, it actually makes your computation faster. Do you understand the concept? I'm trying not to explain in technical terms. I'm just using very simple one. So I just want you to understand how it works. And I give the analogy of the web browser. Is it okay? So these registers, they are actually like memory storages. So these are the terms that we'll be using. So that's the first one, registers. The second one is this theoretical aspect. It was asked in quite some time ago, but then it has lost its popularity to theoretical. But if you see in your past test ones, they have asked this question. So I cannot promise you. But this all, whatever you see in chapter 1, there are a lot of theoretical questions can be asked, starting from this point onwards. The previous one, this one don't bother. What is that to memorize something? Simple. So next we go to the next component, which is ALU, arithmetic logic unit. From the name itself, you know that it performs numerical computation and also logical operation of the processor. From and or and things like that. Is it okay? Are you all following? Are you all hungry? I'm very hungry. Then we have the control unit, the last one. Now, this is quite popular question, this control unit. Sometimes when I say popular, you can actually put asterisks and marks and things like that. Because sometimes whatever I say comes out in the final. Sir, you setting the question, what? Of course it will come out. I'm not the only one setting the question, there are also people setting the question. So the last one is the control unit. Now from the name itself, you know that this particular unit is to control. Now the question is, what does it control? So the control unit contains the hardware instruction logic. I'll explain all this. These are some of the terms that you might find it difficult to understand. Decodes and monitors the execution of instructions, oversees the resources of CPU. Maintains 2 registers. This one is quite famous, they have asked this. So what does it mean by contains the hardware instruction logic, decodes and monitor execution of instruction and oversees the resources of CPU? I'll try my level best to explain it as simple as possible now for you to just get the broad picture. Then later on when you actually go into it, then you'll understand how it works. Don't worry about how it is actually works. Just understand the concept for now. So this control unit is here. Now this memory is, as we have seen just now, it has 2, right? Program and also data storage. So whenever this particular computer is on, the computer is something like, assume that this control unit is like a genie. You know what's a genie, right?
Yeah.
Okay, accepted. Disney had some education. So this control unit, it won't know what to do. These are just hardwares. They do not know what to do. So we as humans, we write the program. We write the particular program on what should the hardware do. Are you following? So we write the program what to do. So when you on a particular computer, this control unit will go to program memory and it will take the instruction. Instruction means there's a program codes which you write. So it will capture the program code line by line. The actually program is actually line by line, the sequential programming. It will take the instruction, the first instruction, it will bring it back to control unit and it will decode the instruction. Once it has decoded the instruction, then it will know what to do. I mean, let's say you actually program the hardware to perform addition. So it won't know. It will actually go to program storage, it will fetch the first instruction, it brings back to control unit, it will decode the instruction. Then only it will know, oh, now I'm supposed to do addition. So based on after the decoded information, it knows, okay, now it's supposed to go addition. The next thing is it will manage the resources of the memory, or you need to use, for example, if you need to add two numbers, the control unit will go to data storage, it will fetch the two numbers, it will bring back to ALU and it will add them up, and then you have a result, right? That result it will actually store back in data storage. Now this whole process, who's controlling? Control unit. Is it okay? Very, very simple terms I'm using. Any questions so far up to this point? Yes or no? Answer something. Yes. So this control unit, further it actually maintains two registers. What are those two registers? Program counter, which is also the abbreviation is PC. What does it do? It keeps track of the address of the next instruction to be executed. And status register flags the instruction execution result. An example, the occurrence of overflow, addition, carry, subtraction, borrow, etc. So control unit it maintains two registers. Registers means it's a memory location. So program counter and also status register. Now what do you mean by this? Keeps track of the address of the next instruction to be executed.
Command.
So let's look at the structure of a memory. It is something like a shelf. So let's say you have the first instruction here, second instruction, third. For example, in reality it doesn't look like this, later you will know. So let's say this is your program memory. Okay, this is your program. We have two memories. One is program memory, one is data memory. But why are we looking at program memory? Because inside program memory is where it contains the program. So let's assume that the first location is the first instruction, second instruction, third, fourth, fifth. Do you understand? Are you following? So this PC program counter is a pointer. It is a pointer. It points. PC is a pointer. Now what does it do? This is actually the first address, and the address keeps increasing. It goes down like that. Okay? So the first address is actually, it has a name of reset vector. The first address, the first location is known as reset vector. Now what does it mean by reset vector is whenever you power on your hardware, this PC, which is a pointer, it will automatically point at the first starting address of your program memory. Now have you all experienced with old PCs? The joy of resetting the PC whenever it got stuck. I'm not so sure whether you all were in that era or not. But during my time, we were still using floppy disk, even the big one. I was still using that. Just imagine submitting assignments using that floppy thing. Anyway, it's not known as floppy. It's not floppy. It's floppy. So, what was I want to say? So when you use the computer and suddenly it got hang. Now those days PCs, you have this button, reset button, right? So when you press the reset button, what happens? Again your Windows starts back all over again, right? That is because maybe your pointer have gone somewhere, but then it got stuck. So when you press the reset button, automatically the pointer comes back to, you understand? So each location has an address. This one got address, each one got unique address. Why you need unique address? Definitely you must have a unique address lah. This one is address 0, this is address 1, 2, 3, 4. The address will be incrementing. It will be incremental address. But each address will be unique. So what it does is when you reset vector, what does the control unit do? The control unit will actually ask the PC where is the location of the first instruction to be executed. So the PC is already pointing to the first address, right? So whatever here in the first location will be taken and from here will be taken and brought to control unit, and it will decode the instruction and it will perform, it will execute it, what the instruction is supposed to make it do. Are you following? Now while after it has fetched and while is it executing, what happens to the PC is it will automatically increase by 1. Why? Because this instruction you have taken already 1. So automatically it increased by 1. So after executing the first instruction, the control unit will ask PC, what is the address of the second instruction to be executed? So the PC already pointing here, this is the second instruction. So it will come and take the second one. And while executing, what happens? It will increase and it will show to the next one. So this is what it means by keeps track of the address of the next instruction to be executed. Do you understand that? Once the first one is taken, what happens? It automatically points to the next instruction to be executed. So after the control unit is done with the first one, it will ask, what is the next? This is the next. So it will fetch the next one. Then automatically increase. After the control unit has finished executing the second instruction, it will ask, what is the third? That is already pointing to third. So do you understand that one? It keeps track of the next instruction to be executed. Any question up to this point? As much as you all hungry, I'm hungry as well. Yes or no? No. The next one is, it also, of course this one will go in detail later. I'm just showing you. I think this is easy enough for you to understand, right? The next one is status register. Now before this, we did the numbering system, right? We did a tutorial and we found out whether there is overflow, is there a carry, and things like that. But how does digital hardware know whether it's a carry or not? Whether there's a overflow or not? So of course, when we do the calculation, we can write there is overflow to indicate that the calculation is overflow. But in digital hardware, it needs a special allocated space for it to actually indicate whether there is a overflow or not. So that register is known as status register. From the name itself, you know that it actually keeps track of the status. Now each time flags means it actually makes the indicator 1 or 0. So later we will see what is the content of status register. So whenever you perform the execution results, especially whenever you do arithmetic operation, if there is an overflow, it will indicate there is an overflow. If there is an addition, carry, subtraction, borrow and things like that, it will be indicated here in the status register. So the status register will actually denote the status after you perform a particular operation. Is it okay? I mean, it will know whenever you perform calculation, it will know whether there is overflow, is there a carry or there is a borrow, things like that. So that will be indicated here. Conceptually, are you understanding? Yes. It depends on the instruction. For example, if that instruction is something to do with addition and also subtraction, yes, it will check the status. But if an instruction that doesn't perform any operation, for example, if you want to say what operation that we have, if you want to load a particular value, some instructions like that, which doesn't require you to check the status register. Because let's say if you want to load a value into a particular storage, when you load a value, there's not going to be overflow, there's not going to be carry, there's not going to be easy carry, there's not going to be borrow. Because the task that you're doing is just moving a value to another location. So those kind of instruction, the status register is not being checked. So it's a very good question. We will see which instruction that involves the status register as we go along. Is there any other question? So control unit maintains these two, PC and also status. This is quite famous question. So now we have seen out of when we actually focusing the computer structure. Computer has two elements, which is software and also hardware. Software we put aside, we are focusing on the hardware. When you take the hardware component, there are four components. Those are CPU, memory, input and output. Input output we actually will see in chapter 7. So we have two more. It is the CPU and also the memory. So we actually now went in depth for the CPU. CPU has three components. What are those? Yes. So the next thing is we're going to focus on, before we go to the memory, we'll see some terminologies. So, if you notice that I mentioned earlier in the introductory class that by right the subject name not supposed to be Microprocessor Systems, it's supposed to be Microcontroller. We're actually using Microcontroller. So sometimes students tend to get confused between microprocessor or microcontroller. So let us clear this down. Now this definition was also asked in test 1, some of the semesters, quite famous also. So what is the definition of a microprocessor? Now basically microprocessor is this. This is a microprocessor or processor. So a processor implemented on a very large scale integration, VLSI chip. Are you familiar with this term, VLSI? Okay. Okay, there is these terms, very large scale integration, there's ultra large scale integration, there are few terms. Now how do we actually determine this? There's a particular range to actually for a chip to be categorized as VLSI. That means if the particular chip has this many millions of transistors, that means it actually categorized until VLSI. If it contains this much, it contains different categories. Is it okay? So that's actually lower than this, but I don't remember. I studied in diploma time. So they have different scales. So very large scale integration chip. So that means on a single chip, the microprocessor is actually done on a single chip. So how are we going to comprehend this? Intel. All of you using, most of you use Intel or AMD, right? What is that Intel or AMD? Is that a computer? That is the microprocessor. Of course, it is the Intel chip has actually exceeded VLSI. It is actually not VLSI, it is higher than that because the number of transistors inside the core chip is actually in billions or billions. I don't know what's the count now. I'm not keeping track of that. So on a single chip, that is microprocessor. Is it okay? So the AMD processor or the Intel processor, that is microprocessor. So peripheral chips are needed to construct a product. So what does it mean? That the microprocessor cannot run by itself. Have you all opened up your desktop PC or your laptop? Have you seen the internal structure on the motherboard? That is the main motherboard. On the main motherboard, you can see one of the largest components, the fan, is actually on top of the CPU. Now on the motherboard, you can see some other chipsets, other small components like. The other components are actually required because CPU alone cannot run the whole system. Other peripheral is actually, if chips are actually required. For example, you need a chip for the graphic control interface. You need a chip to actually control the input output on the motherboard. So there's a motherboard, and the motherboard has a CPU, and there are also other peripheral chips to control the input output. Other peripherals on the motherboard. Is it okay? I mean, the point I'm trying to say is the processor alone cannot do anything. Now there is a term known as the microcomputer. Actually, this is a very old term. During my time, we used to call a desktop PC a microcomputer. If those people knew that we had smartphones, they would be thinking twice of using back systems. So what is a microcomputer? Basically, microcomputer is a normal laptop computer. It uses a microprocessor as its CPU, which means every single electronic device or a smart tablet or a phone which has a processor, it is actually a microcomputer. Are you getting? Microprocessor is just a chip. Microcomputer means it uses the chip as its processor. And then you have this term microcontroller, MCU, microcontroller unit. Now this is a computer implemented on a very large scale integration VLSI chip. Can you see the difference? This one and this one? This one, on a VLSI chip, you only implement this one only. Whereas microcontroller unit, this whole thing you implement on one chip. That's the difference. Now for those who came for the first class, remember I actually passed out the microcontroller. I showed you the black chip, right? Now the black chip is actually a computer. Now why do I say the black chip is a computer? Because inside the black chip there is a CPU. Inside the black chip there is a memory, and inside the black chip there is input and output. The input output is the pin of the chip. So that one chip is a computer. It is not a processor. If you take the Intel processor, that is a processor. But if you take microcontroller, it's a computer on a single chip. Do you see the difference? Of course, there's nothing here to see. I'm just visually asking you whether can you follow. Is it okay? So these are some of the features of PIC18 microcontroller, which even if I explain now, you won't understand. So as we go along, you will get to know about these features. So what is the actually application of microcontroller? We are focusing on microcontroller actually now. So it is actually used as controllers. From the name you know, it's a microcontroller. It's like a computer. It's used for displays, printers, washing machine, microwave. Okay, to cut things short, every single electronic thing has a microcontroller. Every single electronic thing has a microcontroller. As simple as that. You can't run away from microcontroller. So, and then you have another term which is known as embedded system. Now, embedded system is one of a very, very prominent field. It is very, very in demand, embedded system. Now, what is this embedded system? Embedded system is a product that uses one or more microcontrollers as its controller. The end users are only interested in functionality of product but not on the microcontroller itself. So cell phones, home security system, automobiles and many other products are examples of embedded products. Now, basically every single thing has a microcontroller. Sometimes it depends whether you have one or more. So your tablet is an embedded system with this microcontroller. For example, car has multiple microcontrollers. Different microcontrollers to control different things. One microcontroller maybe to check the airbag system, another microcontroller for they have different microcontrollers. So embedded system can have one or more, but usually the users, that means we are the consumers, we are the users, we are not bothered about the microcontroller. We are only bothered about the usage or functionality. You don't go, let's say if you want to buy a washing machine, you don't go into electronic appliance, then you see one washing machine, okay, this is good, how many kg? It's not got fuzzy logic, intelligence or not? You don't see that, right? Fuzzy logic, oh, very good, this one. What microcontroller are you using? PIC. We don't ask what microcontroller, we just basically want to know what it does. So you don't go into BMW showroom and see this car all computerized. Is it using PIC18? No, you won't ask about what microcontroller. The users are not interested in what microcontroller you're using, but they're only interested in the functionality, how it works. So those are embedded systems. So next we'll actually look into memory technology. So between CPU and the memory we had some stories in between. So now we're going back to the memory technologies. So let us start off first with some basic memory technology. Now this one also they have asked in test 1. As I mentioned, chapter 1 has a lot of scope for a theoretical question. So when you take the memory, semiconductor memory means the electronic memory, all in integrated circuit. So basically it can be broken down into two broad technology. One is random access memory and read-only memory. This is, I feel, is one of the most simplest thing, but this is one of the most common mistake that students make as well. Now random access memory is actually a volatile or non-volatile. Do you know what's volatile? Volatile means it can get erased.
Yeah. Random access.
Random access is volatile or non-volatile? It's actually volatile because if the power supply is not provided, the data will be erased. Just like computer, lucky enough, the application is actually somehow or other linked to a storage. It actually stores whenever your words crashes, then when you open back, you can recover back. Nothing will come. During those days when I used to use Word, you know there's a dog icon. There's a dog. No?
Yeah, dog.
It's a pin.
Pin or dog?
A pin or dog. Pin or dog. So the guy will come and irritate you, he'll knock on the top. Keep quiet. So I still remember that time during my diploma times, you'll be typing, having the floppy, that's the only thing you have. During my time, if anyone have thumb drive, me go, you're the god. that time is only introduced the thumb drive. So most of my friends, they got girlfriend because of thumb drive. They got thumb drive. So handsome. Yeah, thumb drive. This was the era where thumb drive was considered among gods. Those who had thumb drive,
Playboy.
it's a playboy. I used to travel in a box of biscuits, put corrupted. The amount of irritating thing. So come back to the point, we used to be typing a lot of programs, and during polytechnic time it's not luxurious like uni time. So we used to cramp up in one house and be typing, and things will be everywhere. You wired extension, one extension, you put extension, you put another one, extension, you connect until it goes second floor. Same extension. So someone will accidentally trip the thing and the whole thing goes off. And we end up cursing so many people. But nothing happened. So if it's gone, it's gone. There's no storage. So that is the disadvantage of RAM. But it is required for you to, as long as the power is there, it's fine. Power is off. Then you have this read-only memory, ROM, can only be read but not written by the processor, or it is actually non-volatile. So where can you find this ROM in your computer?
Startup.
There are, of course, startup. You can see the startup part. If you remember the old PC when you start, you can hear the sound, clink, clong, the floppy will check one by one, the CD will start clicking. Then it will go to your hard drive. That depends on your boot sequence. Do you know when you on, it actually asks whether you want to go to the BIOS setup? That BIOS is actually operating system which is stored inside a ROM. So because it's stored inside the ROM, whenever you on, the first thing it will do is it will load the program from the BIOS. The BIOS will actually check the peripheral, it will check the diskette thing. That's why the old PCs, nowadays you don't hear the sound, but during my time, when I on, you can hear the crank, and some musical factory happens. Then only the Windows will come. It will take like 5 years, Then it will come and it will take a very, very long time. So after what the BIOS does is, it checks your hardware, is it okay? Check one by one. After all okay, operating system, come in. Then only the Windows will come. 9.15 version. Are you okay? So whatever you store inside the ROM, even though power is off, it always stays there. So you have these two basic technologies. Now let us focus in each one of them, because under each one of them there are different technologies as well. So when you take random access memory, RAM furthermore is actually divided into two. Of course now we have DDR and so many other technologies as well. But basically these are the founder of the other technologies. So dynamic random access memory, DRAM, and we have the static random access memory, SRAM. Now the difference between these two is, here you see need periodic refresh. Which circuit always need a periodic refresh? Transistor, capacitor. Yes, capacitor. Have you all learned about RLC circuits? Resistor, inductor, capacitor. You know why it used? Hiya. very, 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 very important. You can do a lot of things with the RLC circuit, you know. It's such a powerful basic circuit. Unfortunately, it's actually not explained properly to you all. When during my Polytechnic time, the RLC circuit combination we used to do a lot of things. Anyway, let us not dwell into that. So this one used capacitance technology, so that's why you need periodic refresh, but you don't have to worry about this. I'm just stating. They won't ask you this in test. And then you have static random access memory. This one is using transistors, so therefore you don't need the periodic refresh. So basically there's the capacitance and also the transistor technology. And then you see under read only memory. Now random access memory